and I found a couple of these 3/8-inch holes where they've been digging. So
oh, he's talking about
today, so
carpenter bees.
That should take care of them. Plus, I bought some traps. You can buy them.
Okay. Summary on this real quick. As in the Deluxe Versa Tuner 2, the inductance setting on this inductor, their chart matches what I found in two radically different antennas. The transmitter antenna capacitor settings, of course, were different, but I found that these settings here were very close. These are very good starting points. Worked everywhere except on the lowest frequency, but my antennas are nowhere resonant on that, on the 160. So I have two antennas real quick. One is resonant on 20 meters quarter wave, and here's one that's just kind of a listen antenna that is most close to being resonant on 80 meters. It's way too low to the ground. And then the particular settings for the SWR being perfect. One, all these settings on here, this is the frequency, match very close to these. In fact, I started with these, and on every one I was able to pretty much find where the SWR would go to 1. That's the purpose of this video, and afterwards I'm going to go into the details. Okay, here's some more on the MFJ 969 Versa Tuner II, the deluxe model. I've got it hooked to an antenna outside that originally I called my listen antenna. It's just a piece of wire that goes up to a small tree and back down. It's really too low, so I just strung this up on a lot. It's only 10 degrees off the ground, which is pretty terrible. But anyways, the feed point is connected to a choke coil, which is 12 feet of Mini 8X, and then there's 18 feet that goes into the house. This is to force this to be resonant and not the coax, and there's a bunch of different radials I've hooked up. This mount is basically a mirror mount from the CB era, in which I drilled a bunch of holes, and I've got, when I got a ham license eons ago, I went ahead and hooked a bunch of radials up. And I've got that antenna, and then I've got one I cut yesterday, resonant on 20 meters, which is just 5-meter wire from the same point here, running up to the top of the roof. And this, actually I made some contacts pretty good yesterday. But I want to show on here that the chart here from MFJ actually is really close, even with these two hokey antennas I hooked up. The first antenna here was the 75-foot 20-meter wire, and all the settings on here that MFJ has for the inductor are a very good starting point over here for mine. This 75-foot antenna is fairly close to being resonant with an analyzer here around 40 meters. There it is at 13 ohms. But anyways, you got about 107 on the inductor, and over here it was 107. So only place mine really deviated was on the one that was on 160 meters, because I ran out of coil. Mine's way off resonance, so I've got it way down here to 0, where I got the optimum rough tuning. And all the other ones on here within a few points. And so the cheat sheet I made up here, all these settings of 7 and let's say 107 3.5, here it is 7.5, 70, 4.5. That's what's up on here. Transmitter, and then the coil setting down in here, and the antenna. So once I made a cheat sheet up, it seems like I can find it fairly quick. And I did that because it's just very frustrating to use this thing. Now if I go over here and listen to a QSO, and then I go through, and this is with the tuned. If I go from tuned to non-tuned, it doesn't really make that much difference on listen, because this particular antenna that I've cut is just about resonant anyways. And so the settings on here are not doing that much of a huge transformation. Now in these other settings where the antenna is way off resonance, like on here on 18 megahertz and it's 434 ohms, you've got a bigger transformation going on, and what happens with that is that you'll have a bigger difference between bypass and non-bypass. It'll sometimes almost be night and day, and then the tuning on this can be very sensitive. That isn't necessarily a good thing. That can mean that you've got it to where you've got some losses going on. Like in this particular case, at the connector it's 434 ohms, and that means that you've got to do a transformation of 10 to 1 to get it close to 50. I'm just assuming the J would be 0 there, which it isn't. But this other antenna I've got here, I cut yesterday, goes from the same choke coil here with the radial system, and I've got it up to a piece up in a tree. This is 5 meters, and I cut this 2 different lengths. I had it a little bit long, and I cut about 1.5 feet off to get it foot and a half off, about 16.5 feet. And that was close enough to be fairly resonant on 20 meters. And let me turn the radio down here. This particular case here on the 5 meter antenna, 16.5 feet. If I go through and look at I ran an analyzer on here, network analyzer, and at 14 megahertz here, it was 30 ohms minus 23J. And I couldn't really get it to be, perfect, because I got a lot of loss with the crummy ground system. But if you look at the resistance on here, this is the frequency: 1.9 megahertz, 3.8, 7.25, 14.2, 18, 21, all the different ham bands. There's a CB band in case somebody's excited about CB. And then there's a 10 meter ham band. There's a 6 meter. If I go through with this wire that I had set up, which is basically like a quarter wave at 20 meters, because I've got this choke system. Now the choke is basically just a coil of RG Mini 8 that I've got. Without that, you're going to tend to radiate on the line because my ground system isn't the best. What you really need is a huge number of radials. Again, back to here, like at 1.9 megahertz, I got down here at 1.2 ohms, very small resistance, so you're going to have a huge loss in the ground system. Here it is at 3.8 megahertz, 2 ohms, 40 meter band, 15 ohms, and then at 20 meter band I got 30 ohms minus 23J. And what that means is on here that if I went ahead and just ran this without a tuner, you might be able to transmit the SWR in there probably is around, I'm just guessing, probably 2 to 1 or something like that, without any tuner. That's why the settings on here, 0, 116, 4, I've got the transmit all the way over here to where you're using the full amount, and then the 4 over here, you're not, the efficiency of the tuner is actually very good in that type of setting because you're using a lot of the capacitance on here. And then that, even with the resonant antenna here, you've got 116, and notice here that's the trial number I used. I was able to get a resonance right on there, 116, 116, 0, and 4. Now if you deviate a little bit on the inductor, you can probably still find the settings often to get a resonance to where but you can't, if you go too much over, you're going to end up having to where you're not using as much capacitance. You want to try to have these most counterclockwise, so you're close to the 0 on either one, if you can. You may not be able to. Now going over here to double, you start to go up here 18 megahertz, you got resistance 295 ohms, so that's way the heck up there. Here you've got 6.3 ohms on the 15 meter band, and then up here you got 14 ohms, 60. So that'll tune fairly well because you're getting close to 50 ohms again. Now when you're actually looking at the numbers I picked up off a network analyzer, those are actually at this connector here. And they're not necessarily what's happening at the antenna, because you've got a transformation on the Smith chart what's going from here to here, because you got a fraction of a wavelength. You'd have to really have the network analyzer right here, or you have to transform this point over here. If this was exactly half or a quarter wavelength away, it goes around the Smith chart and you'll get different readings. So again, these numbers I'm getting here are actually what I measured at this port, and that was with this tuner in the bypass mode. Now if you take the whole tuner out, you're going to even get slightly different things because the tuner isn't perfect. You'll get, so if I tune this up just with a network analyzer and then put this in bypass mode, in the same analyzer, I'm going to get a different type of setting, but it's close. And then the numbers here, which is amazing on here, that I've got worked really well, and that's the purpose of this video, is that these numbers here are very good trial points to try with the inductor. So the antennas that I have are completely different. This one basically is resonant, quarter wave, roughly in the 20 meter band, say 14 megahertz. This one is resonant about on the 80 meter band, I believe. It's where it was mostly resonant at. And those two different, wildly different antennas there that are got different amount of losses and everything, they all tune up with the inductor here on the tuner with an analyzer and just listening on the radio, or with measuring SWR on the radio. They do, trial numbers here actually work very well. Only when I was way the heck off, like on the 160 meter band, which neither antenna is going to be worth a flip because it's way too short, was it way off. There's a 5 and a 0. And if I go over here, and now I'm going to go up and purposely go through and tune on the 80 meter band. So I'm going to go through and hit the radio here, go up the 80 meter band. I'm going to flip through, find somebody. So the trial numbers I've got on here for that particular antenna were 107. If I go over here, and that's bypassed to 9 bypass. So actually, because I haven't tuned this tuner yet, it's actually worse in the tune position because I've got it off. That's another way to see that you're really kind of screwed up in the tune setting. You change a band, it might be better just to use this in the bypass mode because it's actually worse with the wrong tuner settings. That may not be apparent, I just wanted to point that out. So we're going to go through here and turn this to 107. I'll turn the audio up just a little bit. And I'll set this over here to 7.5, 3.5 real quick. 7.5, 3.5, and then I'm going to go ahead and purposely tune the inductor. And going up a number is actually down in inductance. So going up in numbers, there's Here's 107. I'll do a minor tweak here. And I screwed up, I didn't have this in, there it is in tune mode. And I'll watch this S meter here. I'll go ahead and tune the dial here. Right there it's peaked. And sometimes it's better just to go off here and just look at some noise. More random. I've got this on 10. It's peaked there about 8. And just going through and using audio to listen like that often is a good starting point. Now if I go put this in transmit here and look at the forward and reflected power, it's probably going to be off some. And so if you tune the power way down and then you go through and just so you don't scoop somebody's QSO up, go where there's nobody transmitting, and you go through and transmit a carrier on there, you're going to get some reflected power. You can sit here and tweak this in to get the reflected down or the antenna way down. And if you don't get a minimum, you can tweak this just a little bit. It's not good practice to send a signal out there without and blast somebody away. That's really bad, but sometimes that's the only way you can kind of do it. That's why I've got a cheat sheet here, is to minimize the amount of pollution of the airwaves that makes any sense. Just listening for the peak generally is fairly decent. Now, on the 40 meter band here, because you got a lot of noise, just because this peaks here, you still could be having SWR of 4 or 5 to 1. It might be that you've got a huge SWR here that's 20, 30, way the heck off base, and this is just getting you in the ballpark. It's not really got you into your seat, if it makes any sense. And on the HF band like 40 here, a lot of times the if I transmit with this now to try to make a contact with a crummy antenna like this, I can often hear people with an antenna just strung around the room here. And even with this outside antenna, I'm going to go ahead and put, get some watts out, but the efficiency compared to like a dipole is going to be kind of crummy because I've got not enough radials. You're going to have a huge ground loss here. And this is low to the ground, so a lot of the signal is going to end up going way the heck up in the air. So this, again, this works a very good receive antenna. This is super crummy for transmit. It's just something I'd rigged up playing around. The efficiency that you have for transmitting relates to the radiation resistance of this active part of the antenna to the ground. And if you've got a poor ground here, and then this is just a few ohms, you've got a huge amount of power just going up, heating up the ground, and the worms and the flowers, whatever, the grass. And so very little gets radiated. You may only have a bad system. You only get, 10% may actually be radiated. And then to compound that, it may be just going straight up because this is so low to the ground. And so it's basically like yelling, but you're not trying to get hold of somebody far away, but you're aimed the wrong direction. So your voice is just going in the wrong place. Now this antenna here that I had that was 5 meters long at a 60-degree angle, this actually worked really well yesterday just playing around. This is just a 14 gauge wire I had hooked up to the same ground system, and it works so much better because the length of this quarter wave element compared to the radials I have is it's getting close to the size of the radial. So you've got more efficiency going on. It's at a higher angle here. And I made contacts yesterday to somebody in Puerto Rico, Boston, California, Somebody over in South America, just with this 5 meter in length wire here that's connected up to this crummy ground system. Without this choke here, years ago I had something like this hooked up in an apartment. I didn't have a choke, and then what happened is the whole feed line radiated. I ended up blowing up some speakers that I had. I had an amp that was hooked to an old CD player, and I didn't realize it was on, and as soon as I transmitted, I blew up the tweeters, so I religiously put a choke in there. And you probably don't need a choke if you've got a really good ground system here, but if you've got a poor ground system, you're going to end up trying to transmit here. So this choke coil ends up forcing to, you're going to tend to radiate only on this active element. And like I put it out, it's mentioned in another video, I think the settings on this are backwards in the manual over here. Maybe somebody can comment to see if I'm full of it. It says the roller inductors. I've changed this to say it's the maximum inductance in the fully counterclockwise position. Highest number around 117. So at the high frequencies here, you're using very little of the inductor. Very little of the coils used. So this is low inductance, high inductance. So low frequencies, you're using a lot of the inductor. And so I think they've got this paragraph wrong. I mentioned that in the other video. And then these cheat sheets like this, as long as you don't change an antenna too much, they're good starting points. With this antenna over here that is resonant fairly well on 20 meters, the SWR over the 20 meter band here, this 30 ohms minus 23J, if I go ahead and change all over the 20 meter band, the SWR is fairly close. In fact, I can tune this to the middle and go all over the place, and the SWR is very little changes because I've got the antenna close to resonance like this. Now if I got some goofy thing like this in this listen antenna that I'd used for years, I just was playing around yesterday with transmit, it's way off resonant. Like on here, if I want to go listen to the 15 meters, 21 megahertz, and you got 6 ohms minus 23J. With that type of thing, when you crank in the settings here on the tuner over here, and you go off frequency, let's say I hook this up at 21.3 megahertz, then I want to transmit at 21.35. If the SWR here is 1, and I want to go through and move off 50 kilohertz, 100 kilohertz or something, it's going to go up. And it may be okay, maybe not okay. If you've got a big transformation, you're going to go to where you go off resonance or off the SWR is going to change a lot. And that's not necessarily due to the antenna is not changing that much. It's just the transformation is going through and changing a lot. Compared to the length of this antenna, if I change 100 kilohertz, that's very little on the length of that big antenna. And then it's a lot on the transformation of this. So again, if you go way off frequency, like on here, this antenna is resonant on 20 meters. I can pretty much go all over the 20 meter band when this is tuned up here on these settings 0, 1, 16, 4, and it isn't really a big deal. The SWR doesn't change very much. But go way off, it's very touchy. So if I go up here to the 10 meter band, 15 meter band, and whatever settings I've gone ahead and set here, if you want to go up 100 kilohertz, you need to go ahead and change. And what will happen is that these settings are really good to start with, but you're going to probably have to go through and put it in listen mode, and you can go ahead and tweak these just a little bit, and you can go ahead and you'll hear a little bit more noise, and that's a good starting point if you want to dial in the SWR with actually a transmit cycle. Now if your antenna is totally perfect resonant, you don't have to use a tuner. A tuner is kind of a necessary evil to keep your transmitter happy, so you don't burn up the finals or, you know, something like that. They're not perfect, which means if you've got 100 watts coming out of this thing and you go through a big transformation here, you might have, you know, you might have half the power, a quarter of the power, heating the darn inductor off. Now, if I go down here to 160 meters, 1.9 megahertz, where my antenna, you know, is way off, like on this thing, you might have a whole bunch of power just going and heating up this coax, and very little being transmitted. And so, yes, you make the transceiver happy, but you don't really have that much useful power going out to listen, I mean, to communicate with somebody. That's one of the problems about antenna tuners. I'm not sure everybody understands, but when I first got into it, you always thought it was some magical device. It's just basically trying to make the transmitter happy. Now, whether you actually get real power down here is a different story. Useful power. You got a short antenna. If I use this little short antenna tuned for 20 meters on, say, 160 meters, the was 1.2 ohms, J21. So, of course, because it's so short here, it's capacitive. You really, if I put a coil down in here, then I could go ahead and get this to be where I could go ahead and probably have less loss on this line. Now, if I wanted to be a tooler, what I would do, I would use hard line from the tuner all the way to here, and I would use a bigger choke. Now, if I did all that, what would happen, you'd have very little loss along here, and you'd put more power into here. Another thing is to go ahead and put a huge number of radials, and you've got a lot of power being lost in a radial system when you don't have in the ground where there's no radials, because you have power current that's got to come back through this feed point. It's going through the ground, it's going through anything it can, and it just heats it up. You can't really see it unless you're going to put gobs of power into there. You're never going to see the power lost. And then the third thing is you've got power radiation going off, you know, in this particular antenna here, it's just going off into vertical because this is so low to the ground. You're going to get a pattern that's going to go through, and an antenna like this from the side view, you transmit, you're going to get a lot of power that tends to go straight up like this. Very little is going to go at a launch angle like this that you really need to have for DX work, because the antenna is too short to the ground. Now, if this entire antenna was lifted up, say, 100 feet in the air, and I had it as a dipole, so I don't have a ground system. I've got one radial over here, another radial here, and you feed this, then you get a pattern where you're going to launch more like on here, at a lower launch angle. Now, this particular one here where I've got, get the zoom on here, this is one leg of a 20-meter antenna. This is a vertical. If I had this as a totally high conductive surface, like on here, like if the connected up to solid aluminum, salt water, whatever, then you'll get, from the side view, you're going to get power launched off at a low angle. But with a poor radial system, what you have, this antenna, I tried to get it close to being a vertical, but you get a lot of power that tends to go straight up. To get this launched off at a low angle, what you really need is you want this to be, the entire surface here to be very conductive. And that pulls the lobe way down, close. There's a book by Lee that goes into that on vertical antennas. Anyways, this is a rambling video put out. Mostly the prime reason I did this was just to show that the inductive settings are very close. I was very much surprised. In fact, I thought this chart was actually fairly hokey, but it turns out it's very good. So I've got two radically different antennas, and the inductor over here setting is very close, actually, even for antennas that are way off resonant. There's coax 2, coax 1, balance wire, dummy load. This is the Versa Tuner II MFJ 969.